Finally, we're going to look at verifying similarities on a coordinate plane. So if we think back to section 3 of how we prove triangles similar, we had 3 methods. We had angle, angle, side, 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 and side, angle, side. You can pick any one of these 3 methods, but the one that I would recommend just sticking to would be side, angle, side. You can really choose any 3 that you want, but if you show that you have congruent angles, you need to show that they have the same slope. And it gets a little bit difficult to show angles can possibly be congruent. Sides are pretty easy to show. You just have to show that they reduce to the same scale factor. You might have to do quite a few distances, but that's okay. So in our triangle right here, we're going to try and find the scale factor to make sure that these reduce to the same thing. So we need to find the side lengths for AB, BC, and AC. And we're going to try and match up its corresponding side lengths. So if I said AB first, XY would have to go with AB, so I'm going to put XY over here. BC would be YZ. And then finally AC would be XZ down here at the bottom. A few of these we should be able to count. So I'm going to skip over AB and XY for now. We're going to go down to BC. BC we know has a length of 1, 2, 3, 4, 5, 6. And AC we know has a length of 1, 2, 3, 4, 5, 6, 7, 8, 9. YZ, we know 1, 2, 3, 4. And XZ we know is 1, 2, 3, 4, 5, 6. We also need to find AB and XY. Those might be just a little bit more difficult because we can't just count those. In fact, in order to find those, we would need to use the distance formula in order to state and find those lengths. So I'm not going to do the distance formula. I'm just going to tell you what those distances are. The way we can move just actually I need to find the distance. So those distances on here, AB, if you'd find the distance, comes out to the square root of 117. And then for XY, it would come out to the square root of 52. We need to verify that these all reduce to the same scale factor. So I'm going to put the bigger one over the smaller one. So we're going to have square root of 117 over the square root of 52. Does that equal 6 over 4? And does that equal 9 over 6? For square root is 117 and square root of 52, I would just plug that into your calculator. So if we type that in, square root of 117, close it off, divided by the square root of 52, that's going to get us a fraction of 3 over 2. Equal to 6/4 reduces to 3 over 2. And 9/6 reduces to 3 over 2. So yes, these triangles are similar by the method we used was side, side, side.